So the second part of the stack and subroutine is the subroutine, which we have discussed already, that subroutine is a kind of a subprogram which is written separately from the main program, just to avoid the duplicacy of the or the repetition of the certain instructions which are being used in a particular program. So the purpose is to reduce the size of the program instead of using the repetitively instructions which are being used for the same purpose. What we used to do, instead of writing it many times, what we do, we put that set of the instructions separate in the form of a subprogram, and whenever it is required, subroutine the main program calls that subroutine. The control is shifted from the main program to the subroutine. Subroutine is executed, and whatever is the result, it is returned back to the main program. So this is how this subroutine used to work. But to implement the subroutine, we are in requirement of certain instructions. Those instructions are called call instruction and the return instruction. Call instruction is used in the main program to call that subroutine, and return is that instruction which is used in the subroutine to return back to the main program. So it is basically the shifting of the control of execution from the main program to the subroutine program whenever call instruction is executed, and then shifting the control of the execution from the subroutine program or subprogram back to the main program when return instruction is being executed. So let us now discuss that how this call instruction used to work. Call instruction is a 3-byte instruction, and the format or the syntax of call instruction is call 16-bit address. So the purpose of call 16-bit address is to call subroutine unconditionally. Whenever this instruction is written in the program, it has to go, the control has to go to the 16-bit address which is mentioned in the instruction itself. So as I told you, it is a 3-byte instruction that transfers the control, that transfers the execution of the program sequence from the main program to the subroutine, which address, which is mentioned in the as a 16-bit address. Now, whenever program is being executed in a normal sequence, it is the program counter content which indicates, which instructs the microprocessor that which next instruction has to be executed, and it is given by the program counter. So wherever the call instruction is written, normally in the normal sequence of the execution, one instruction is executed, then the next instruction is executed, and then the next instruction is executed. But whenever the microprocessor finds call instruction, it has to go to certain other place to execute the subprogram or the subroutine. But it has also it is also required that to store the next execution of the next instruction which is given by the program counter. So what it used to do, it temporarily saves the next instruction's address at the stack. So it saves the content of the program counter, which is the address of the next location, next instruction, onto the stacks, and it decrements the stack pointer. It works similarly as the stack pointer used to work. Whenever something is being stored in the stack pointer is decremented, and it jumps unconditionally to the main program, to the subroutine. Now, what is the purpose of return instruction? Return is a part of the subroutine program, and it returns back to the main program. Whenever return is executed, it shifts the control of execution from the subroutine to the main program. That is why the call and return, these two instructions are counterpart of each other. Whenever we are using call will be used in the main program. So whenever it has to come back to the main program, the return instruction will be used in the subprogram or the subroutine. Call instruction is a 3-byte instruction, but return instruction is a single byte instruction. What it used to do, whatever is stored in the program counter while it is shifting its control from the main program to the subroutine, it used to temporarily store the address of the next instruction, that is the program counter content, onto the stack. So it is the duty of the return instruction to take it back and from the stack back to the program counter. So it unconditionally returns from the subroutine to the main program. So this is how call and return instruction used to work. Here an example has been shown to you in which at 2000 stack pointer is initialized first, and at 2040 call instruction is written. So normally 200 onwards, whatever instruction is being written, it will be executed by the microprocessor. But when it encounters 2040 where call instruction is written, whatever instruction written next to the 2040, it will not be executed. What it will do, it will shift its control to the 2070, because 2070 is the memory location where the subroutine is written. So what it will do, it will call that program. So control will be shifted from the main program to the 2070. So from 2040 it will shift to the 2070, and 2070 we have a subroutine. So after 2040, 2070 will be executed, which is the start of the subroutine, and 207 will be executed, and whenever it encounters return instruction, that gives the indication that it is the end of the subroutine, and it jumps back from the subroutine program to the main program. So this is the statement which has been written for the in the form of explanation. Now this is the figure which gives you the idea that from 2000 program is being executed. At 2040 we have written call instruction, but call instruction is a 3-byte instruction to 2040, 2041 and 2042 will be executed. But after 2042 it has to execute 2043, but it will not do, because at 2040 call 16-bit address has been written, and that is 2070. So its shift is controlled from 2042 to 2070 where subroutine is written. So 2070, 2071, 2073 till it finds the return instruction. So at 2075 return instruction is written, then it shift is controlled from the subroutine back to the main program at 2043. How it gets this 2043? While this shifting is being done from main program to the subroutine, this 2043 is stored in the stack, and while returning, that stack content will be retrieved back to the program counter. So what is its use? One of the application of subroutine is in the sorting, in which the problem is written that write a program to sort the given number in the descending order or in the ascending orders. I have taken an example of a descending order, which is very simple. You know how to sort that number. In the descending order, what process is being done? In a given series of the number, what we do, we try to find out the largest number and put it at the first place, then the second largest number, put it in the next place, then the third largest, and in this way, whenever we are getting all the largest number in that sequence, that number will become in the descending order. So to solve this problem of sorting, we have already done without subroutine sorting of the number, but if we have to take the help of the subroutine, what process we will adopt? So to solve this problem with the help of subroutine, what we have to do, of course we will be using 2 subroutines for this purpose. One subroutine will be used to find out the largest number, and another subroutine will be used to once the largest number has been recognized, has been found and being stored, make it as a smallest number. Because if we don't do this, otherwise what will happen, that every time you will be getting the same number as the largest number. Suppose we have 5 numbers in the series and you got third number as the largest number. Next time whenever you want to get the largest number, again you will be getting that. So the first subroutine is to find out the largest number out of the series of the number, and once it is found that this is the largest number, we will use another subroutine which will be using the same set of given data, and whenever it is matched, it is reduced, it is substituted by the smallest number. So that what we have to do, once we have found the first largest number, and then next time we have to find out the second largest number, but we are able to get the second largest number until we are not going to replace the first largest number by smallest number, and you know the smallest number is 0, 0. So for that I have drawn a subroutine. We have a subroutine, we have drawn a flowchart for that, and in that flowchart we have main program flowchart, subroutine 1 program flowchart, and subroutine 2 program flowchart. So first of all we will discuss the main program. What is the main program? First of all, we have to find out, we have to initialize the pointer source pointer as well as the destination pointer. Source pointer क्यों? Because the source pointer will be indicating that where the input data is written. And why destination pointer? Because at that destination place you will be storing the number first largest, then second largest, then third largest, and ultimately when all the largest has been found, you will be getting the number as in the descending order. As well as you have to initialize the counter also. Then we will be calling the subroutine 1 to check the largest number. Once largest number has been found, we will store that largest number at the destination. Then we will call subroutine 2 to check the largest number and make it as the smallest, that is 0 0. And we will decrement the counter. If the counter is not 0, we will go back to the main program, and again we will be calling subroutine to find out the second largest number. Once second largest number is found, we will store it second largest number. Then we will call the second subroutine 2 to find out that which one is the second largest number, and replace it by smallest number, that is 0 0. Then we will decrement the counter. Again the counter is not, and in this way this will go on. So what is the purpose of the subroutine 1? Let us check what is the purpose of subroutine 1. We will initialize the source pointer because we are in requirement where the data is. We have to initialize the counter, the how many times we have to check, and then we will also initialize the accumulator. So first of all, the same process will be used. This particular subroutine is actually subroutine to find out the largest number. If you have, अगर आपको program largest number का find out करना है, तो this subroutine is, this flowchart is meant for that particular purpose. तो पहले accumulator में पता नहीं क्या, I don't know. So accumulator is checked with the next number. So whatever number is greater, we will try to put that number into the accumulator. If accumulator is already greater, then we will not get the largest number into the accumulator because accumulator is already having the largest number. But if accumulator is not having the largest number, then the condition will be false. Then no, in case of no, what we'll do, we will try to get the largest number into the accumulator. Then we will increment the pointer, decrement the counter, and we will adopt this process till all the counter becomes 0. So this is the flowchart for to find out the largest number. Now once the largest number has been found, now it is our prime duty to reduce it as a smallest. So for that, subroutine 2 has been drawn in the form of a flowchart. We have to find out the source pointer, we have to initialize the counter, we have to initialize the accumulator also, and we have to check that whatever is the content of the accumulator, which is the largest number, is equal to that number or not. So if it is so, if accumulator is find out that it is a largest number, then what we will do, we will come to the replace the largest number by the 0 0. But if it is not so, we have to continue check whether when it becomes same. So pointer is increased, counter is decreased till this process is going on. Okay. So this is the flowchart to find out sorting of the number in the descending order. So now let us check the program. Now program is, first of all, we have to find out, suppose the input data is written at 2501 onwards, and we have to write the descending order number at 2601 onwards. So first of all, suppose I have taken an example of a 6 number. So counter has been initialized into the B register. Once counter is initialized in the B register, we will call the instruction at 2200. Now this call instruction is a call subroutine to find out the largest number. Whenever it goes to 2200, at 2200 subroutine program has been written to find out the largest number. Once it finds the largest number, it will return back, and whenever it will return back, the content will be stored in the accumulator, and that accumulator content will be copied to the memory location whose address is given in the D pair. So the first largest will be stored. Once first largest will be stored, it will call the next subroutine, that is subroutine 2 to check which one is the largest number. And once it is found that largest, it is the duty of that subroutine to convert or to substitute it in the smallest number. Then what we will do, we will increment D, we will decrement C, then this process will go on and on till all the numbers has been sorted. Now you can check that. Now see, in the main program we have to initialize the pointer source and destination. So this is the initialization of the source and this is the initialization of the destination. And then the second part is store once initialize the counter has been initialized by this value MVIB06. Now the third statement is call subroutine 1. So call subroutine 1. So subroutine 1 has been called, call 2200. Once subroutine has been called, it will give the largest number, so we will store the largest number. So by the help of STST we are storing the largest number. Then we are using the subroutine 2 to check the largest number. So we are going into the another subroutine, that is 22. This is the second largest number. This is the second subroutine which is trying to find out the largest number and converting it to the smallest number. Now the next is decrement the counter and check the counter. So what we are doing, we are of course we are incrementing the destination as well as we are decrementing the counter, and this goes on. Jump on no zero start. Start means here is the start. So it will continue this process. So now let us check what is subroutine 1. Subroutine 1, first of all, counter has been initialized, source data is stored at 2501, and then we have to initialize the accumulators by subtracting A. Whatever is the content of A, it will reduce to 0, and then we will compare M. What it will compare? Accumulator is already 0 and you are comparing M. M means comparing the content of the memory whose address is given in the HL pair, means the first value, and we are comparing with the accumulator. So accumulator is the smallest because accumulator is reduced to 0. So the first number is compared with the accumulator. So when first number is compared with the accumulator content will be less. So what we have to do, we have to shift the largest number into the accumulator. So jump on no carry ahead. तो जंप ऑन नो कैरी, तो कैरी तो जनरेट हो रहा है. सो व्हाट इट विल डू, इट विल मूव AM. So it means copy the content of memory into the accumulator. Why it is being done? Because it is written in the flow chart that if the number accumulator is smaller and the number which are being compared is greater, we have to find out the largest number into the accumulator. By this we are getting the largest number in the accumulator. But it is not necessary that first number is the largest number. So we have to continue this process. So what we will do, we will increment the source pointer and then we will decrement the counter and it will go to the loop. Again it will compare. Now the first number which is stored in the accumulator is compared with the second number, and in this way it will done. And when all the numbers are being compared, the accumulator will be having the largest number. Now that largest number will be returned back to the main program. Now let us check what is subroutine 2. Subroutine 2 is written at 2250. So first of all we have to initialize the counter, we have to initialize the source, and then accumulator is already having a largest number. So it is being compared with the first number. अगर फर्स्ट नंबर से कंपेयर किया गया और अगर वही नंबर लार्जेस्ट है तब तो जीरो फ्लैग सेट होगा. अदरवाइज क्या होगा, इट विल मूव. अगर जीरो फ्लैग सेट नहीं हो रहा है, अगर पहला नंबर लार्जेस्ट नहीं है तो हम इंक्रीमेंट करेंगे सोर्स पॉइंटर को और उसके बाद काउंटर को डिक्रीज करेंगे और वी विल गो बैक टू द कंपेयर एम. सो दिस प्रोसेस विल बी कंटिन्यूड. कब तक कंटिन्यू होगा? जब तक जीरो फ्लैग सेट ना हो जाए. और जैसे ही जीरो फ्लैग सेट हो जाएगा, ये क्या कर रहा है, एक्यूमुलेटर के अंदर 0 डाल दे रहा है और इस एक्यूमुलेटर की वैल्यू को हम मेमोरी में ट्रांसफ़र कर देना है. मैंने जो भी लोकेशन पे हमको लार्जेस्ट नंबर मिला उसको हम 0 कर देना, एंड देन इट इज़ गोइंग टू रिटर्न. सो इन दिस वे, by writing this program, by using 2 subroutine, we are able to sort the number. Now as far as the subroutine is concerned, besides call and subroutine, there are certain more instructions. The heading is restart instructions and conditional call and return instruction. So what is the restart instruction? Actually the restart instruction, RST instruction basically it is called. There are 8 kinds of RST instruction whose purpose is to shift the control of execution of the program if it is written in the main program to certain memory location. as I told you that there are 8 such kind of instruction: RST0, RST1, RST2, RST up to RST7, and normally this instruction is being used for the interrupt purpose, which we will discuss later on while discussing the interrupt. So what actually RST0 stands for? It stands for call 0000. This is fixed. RST0 means it will go to the memory location 0000. If RST1 is written, it will go to 0008. RST2, similarly, these 8 RST instructions are being used. Now, till now, whatever instructions in the form of a subroutine we have discussed till now, call and return, they are unconditional. But besides unconditional call and return instructions, we have certain conditional call and return instructions. We have 4 flags through which we can put conditional call instruction as well as conditional return instruction. Now, conditional call instruction will be based on the data condition. Data condition is reflected by the flags. So, if it is a carry flag, if it is a 0 flag, it is a sign flag, or it is a parity flag, all these conditions are being tested, and if the condition is going to satisfy, then only it will go to the subroutine, otherwise it will not go to the subroutine. Similarly, return instruction is also conditional instructions. Besides unconditional, it will check whether carry flag, 0 flag, sign flag, or the parity flag. If it is going to be satisfied, then only it will return, otherwise it will continue its process. So, we have 8 conditional call instruction. First conditional call instruction is CC. CC stands for call on carry. अगर carry flag set हुआ है तो call instruction काम करेगा, otherwise नहीं. CNC call if no carry is set, call if 0 flag is set, call CNZ, call no 0 flag, means 0 flag is not set. Call on minus, if the sign flag is set, then call. If sign flag is not set, don't call. Then CPE is a parity flag. If parity flag is set, then call. If parity flag is not set, then call. Similarly, we have conditional return instruction RC, RNC. This is meant for carry flag, Z and RNZ. This is for 0 flag. This is sign flag. This is for the parity flag. So, but there are certain advanced subroutine concept also, that is nesting of nesting. Nesting is actually loop within the loop. Suppose a main program is using a subroutine, and subroutine may also use a subroutine. Here an example has been shown that it is the main program. In this main program, we have written call 2090. So what it will do, it will shift its control 2090. Now this is the subroutine. Now this subroutine is again calling another subroutine. So what will be happening in the main program? In the main program, first of all, this is being executed, then this will be executed, then this will be executed, and again it is using call instruction. So this will be executed, and this subroutine is executed, and this subroutine will be returning back to this subroutine. And when this is executed, this will return its control to the main program. So this is the nesting of the subroutine. Similarly, in the case of return instruction, we have multiple ending subroutine. Multiple ending subroutine in which we will be using conditional return instruction. At 2500 RZ is written. Return on 0. अगर 0 flag set हुआ है तो return करो, otherwise it will continue. RC return तब करो जब carry flag set हुआ, अगर नहीं हुआ है तो. Now this last one is the return which is unconditional. It has to return to the main program, but this will return these two. This and this will return only if the condition is satisfied. So this is called the multiple ending subroutine. Now this is a chart which is given that what is the comparison of the subroutine operation as well as the stack operation, and this is very simple, that for subroutine we are using call and return instruction, for stack operation we are using the call and return, and for stack we are using the push and pop instruction. So when call is being executed, MUP automatically stores the 16-bit address of the next instruction on the stack. It is the duty of the call instruction to do that. But in case of push and in case of a stack operation, we have to use push instruction to store the content of the register pair onto the stack. So this is the difference between call return and push and pop. पुश एंड पॉप के केस में पुश इंस्ट्रक्शन आपको यूज़ करना, स्टैक ऑपरेशन में आपको पुश इंस्ट्रक्शन यूज़ करना पड़ेगा जिससे कि रजिस्टर पेयर के कंटेंट को स्टैक में डाला जा सके. लेकिन कॉल इंस्ट्रक्शन ऐसा इंस्ट्रक्शन है जो कि अपने कंट्रोल को शिफ्ट करता है सब रूटीन को एग्जीक्यूट करने के लिए, लेकिन साथ ही साथ प्रोग्राम काउंटर के कंटेंट को ऑटोमेटिकली स्टोर कर देता है स्टैक में. When call is executed, the stack pointer automatically, अगर सबरूटीन कॉल इंस्ट्रक्शन को एग्जीक्यूट कर रहा है और वो स्टैक पॉइंटर में प्रोग्राम काउंटर के कंटेंट को लिख रहा है, तो स्टैक पॉइंटर का कंटेंट ऑटोमेटिकली डिक्रीमेंट बाई 2. पुश इंस्ट्रक्शन में भी यही होता है कि स्टैक पॉइंटर कंटेंट इज डिक्रीमेंटेड बाई 2. इन केस ऑफ कॉल रिटर्न इंस्ट्रक्शन इज यूज टू ट्रांसफर बैक टू द मेन प्रोग्राम. तो क्या करता है, रिटर्न इंस्ट्रक्शन की ये ड्यूटी है कि वो स्टैक के कंटेंट को प्रोग्राम काउंटर में वापस डाले. लेकिन स्टैक के केस में अगर स्टैक सिंपल स्टैक ऑपरेशन है तो उस केस में हमको पॉप इंस्ट्रक्शन को यूज़ करना पड़ता है, जिसके कारण जो स्टैक में कंटेंट है वो रजिस्टर पेयर में लोड होता है. व्हेन रिटर्न इज एग्जीक्यूटेड, ऑफ कोर्स स्टैक पॉइंटर विल बी इंक्रीमेंटेड बाय 2. जब पॉप एग्जीक्यूट होता है तो भी, तो देयर आर सर्टेन सिमिलरिटीज बट देयर आर सर्टेन डिफरेंस ऑल्सो. इन केस ऑफ सबरूटीन, अनकंडीशनल इंस्ट्रक्शन के साथ साथ हमारे पास कंडीशनल कॉल एंड रिटर्न इंस्ट्रक्शन भी होते हैं, लेकिन स्टैक ऑपरेशन में कोई भी कंडीशनल इंस्ट्रक्शन नहीं होता है. उसमें केवल पुश इंस्ट्रक्शन होता है और पॉप इंस्ट्रक्शन होता है. दैट्स ऑल फ्रॉम दिस साइड एज फार एज द सबरूटीन इज कंसर्न. थैंक यू.